Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for Computer America, because today on the show, as every Friday, we have the one, the only Mr. Ralph Bond. He is our science and technology trends correspondent, and yeah, we talk about all things science, tech, medicine, construction, space. Ladies and gentlemen, there's nothing that really is off limits, because like it or not, like microplastics, science is everywhere and you can't get away from it. So Ralph's purview is wide, and he definitely finds those stories that you might not have heard about. So, you know, it's not just a rehashing of the same 4 headlines in the week. Nope, we got brand new ones just for you. Now, with that being said, computeramerica.com, that's where you'll find everything, including past shows, future shows, everything you need to know. And of course, the show notes are going to be a huge thing as well, because Ralph spends a lot of time putting them together, including links, of course, little short synopsis or key talking points, I should say, of each story, but of course, sources all of them. So if you want to find out more, hey, he does that for you. Now, with that being said, I think we should just jump right into it and bring Ralph on. And as said before, longtime Computer America correspondent, and of course, you know, just all around nice guy, Ralph Bond. Ralph, welcome back onto the program.
Great to be back, and boy, have we got a fun show today, especially with the first story, which it's all about an amazing kind of Terminator 2-like mini robot. It's just what?
I remember we teased it. We kind of teased that last week, and yeah, you're definitely going to hear about that. So I gave a quick overview, Ralph, but tell the nice new folks who out there who may be new to our segment what our goal is here with our segment.
Sure. So what I do is I monitor a bunch of online news services. In fact, I sent those over to you last week, Ben, to give you a list of all the resources I kind of scan all the time. And I look for stories that a lot of times kind of fly under the radar of the mainstream press, because, of course, there's the war in Ukraine and so many other topics that are so, present in mind, and these great stories kind of get lost in the shuffle. And as you correctly pointed out, I look at things in robotics, medical technology, sustainable energy technology, transportation, space, physics, you name it, across the board. Nothing is off limits. And what we do together really is kind of highlight the essential points from these articles in what I hope is a very digestible form. And again, stressing the show notes, which Ben, if you're able to see our presentation, you're not just listening. The show notes give you links and key points and so forth. And I encourage you to dig deeper if you're interested in any one of the stories, because again, we're just going to give you the highlights. There's so much more science usually behind every one of these stories. So check out those show notes and away we go.
All right, perfect. And of course, we'll always start with story number 1. And, ladies and gentlemen, if long-term listeners know that Ralph used to come prepared with, 20 plus stories. And, that was all fun. We'd get through like 12, 13, 14 of them. And give everyone homework. We've definitely shortened our segment quite a bit. And I think we, pretty much nail like about the half-hour mark with 4 stories. But, ladies and gentlemen, if you want to find out more, these 4, what we say here, as Ralph said, is not the entirety of the article, but just the just the nice bits. So if you want to find out more, check out the show notes. Ralph, story number 1, and again, if you were watching last week, I was amazed that just there on the sidelines of one of our previous stories was another story about a Lego brick looking dude.
Yes, it's great. The headline here is "Scientists create a small, shape-shifting humanoid robot that can liquefy and reform." And that's where the joke about Terminator 2 comes in. It's much like that in a bizarre kind of way. And this is a wild story I got from sciencealert.com. It was covered widely elsewhere as well. And here's the story. Scientists at the University of Hong Kong have created a small, shape-shifting robot that can switch between liquid and solid metal states. Wow. The researchers call their bot a magneto-active solid liquid phase transitional machine. Try to say that again without stumbling. And believe me, this definitely has the robotics world buzzing. This is a story that broke this month. And here's a snapshot. Again, we're just going to give you the highlights. If you want to dig deeper, start checking out the articles. So a snapshot on the technology behind this innovation and what it can do. Well, the researchers used a non-toxic metal called gallium, which is a soft metal that has a melting point so low it can melt in your hand. What? Wow. Gallium has a melting point of 85.57 degrees Fahrenheit, just a few degrees below the average human body temperature, right? So pretty amazing. A little bit more about gallium, because I had never heard of this, and I just thought this is really very interesting. The element gallium is an unexpected metal. It's a soft, silvery white metal that is solid at room temperature, similar to aluminum, but it can literally melt in the palm of your hand. And I've given a source in the show notes for that if you want to learn more about gallium. Well, the scientists created a new composite of gallium and magnetic particles, which liquefies in the presence of a changing magnetic field and moves under the guidance of a permanent magnet. And I want to do a side note here for a moment. Ben, you and I have talked about over the past number of years quite a few robotics activities that involve magnetism, using magnets and magnetism to move things and so forth and so on. So that's not new in a way, but what's new is combining it with gallium to create this shape-shifting, if you want to call it a robot device. It's just amazing.
You could really imagine that, like a lot of robots, if something melts at 85 degrees Fahrenheit, it's like, well, Chief, we have a robot, but the sun's out, so we really can't send it out there. It's just going to destroy itself.
Yes.
It doesn't seem practical in a lot of cases, but this time it seems it was.
Well, it depends, and that's a great point. We'll talk about possible applications at the end of the story here. So, after successful testing using magnets to control the bot's transition from solid to liquid and back again, the University of Hong Kong team made their little robot climb over obstacles, leap over small moats, escape a cage, and there's a really freaky video showing this. It's a lot of fun to watch. And even, here's the really weird part, even split apart to perform cooperative tasks, moving objects around before recombining, and re-solidifying. And there's something to think about. That just makes my brain go like this when you think about possible applications. But wait a minute, time out, reality check. So this technology is at a very early proof of concept stage, but the potential real world applications could be very interesting because of this amazing, capability. The little robot could be used, for example, to navigate around places too small or convoluted for human hands to reach, or perhaps to target medical drug delivery, even within the body, which is really freaky and weird. And to your point about temperature and so forth, Ben, you're absolutely right. You couldn't use this out in the middle of, say, Las Vegas on a summer day. It's just not real. But in many manufacturing environments and other situations where you have lower temperature on purpose environments, refrigerated environments, and so on and so forth, perhaps this could be useful. Within the body, I struggle with that because it would be constantly liquefied, but I guess you could still manipulate it. But anyway, it's just sort of a fun thing to think about, and it's intriguing. And if nothing else, the video is a real laugh to watch.
and the video is definitely worth watching. I wish you got like a little bit better view of it, like reforming, because it seems like it's just a puddle of goo, and then suddenly it's another robot.
Right.
So I wish that was a little bit more clear. I will say though that the human body one makes a lot of sense, because if imagine this little magnetic pool of goo kind of working through your body and working through your gut, and emphasis on non-toxic, it can deliver drugs, and then of course it can go right through your body like a liquid, and then once it's out of your body like a liquid, it re-solidifies back into something that can be retrieved if you're have little sensors in it or whatnot. So the body actually makes perfect sense to me, Ralph.
Yeah. It's going to be interesting to see. And the video, once again, if you watch it, folks, you'll see as the little Lego man, kind of Lego-like guy, passes through, some parts of his little body are left behind on the cage. So it's not perfect, but it's such an interesting possibility.
This other video that they have here that kind of shows the robot actually melting in the human gut and then wrapping around a foreign object in it and then removing it, by kind of moving it through the digestive system. That's also a very interesting video. There's applications, Ralph, but as we've seen so many times in academia, you can have a proof of concept and then you figure out, that's cool. Right. What can you do with it? So
yes, exactly right.
Very cool for the team over at the University of Hong Kong. So that's story number one. Story number two. Let's go ahead and skip right over to this one where, and I'm sure that, you've known some very crafty people in our lives. My mother sews and quilts and does all that kind of thing, and, crocheting. But I never really consider her an electrical engineer. So maybe this next story will bridge the gap between the two.
And in fact, your next jacket or sweater might have capabilities that you can't even imagine. So here's the story. The headline here is researchers create a new type of yarn that turns movement into electricity. I got this story from techexplore.com, a wonderful outlet. And here's the story. Recently, nanotechnology researchers at the University of Texas at Dallas announced the latest generation of their innovative carbon nanotube yarns, and they call these twistrons, which generate electricity when stretched or twisted. Now, time out, ding, ding, ding. And Ben, you know this all too well from our past couple of years. Mm-hmm. This is not not the first electricity generating fabric technology. That's not what we're saying here, folks. But here's the deal. But these new carbon nanotube yarns, which look, feel, and act like traditional wool or cotton yarns, convert movement into electricity more effectively than any fabric-based energy generators developed to date. That's why this story is important, okay? So it marks a nice advancement in this field. Now, in one experiment, the team sewed the carbon nanotube yarns into a cotton fabric patch that was then wrapped around a person's elbow. Electrical signals were generated as the person repeatedly bent their elbow, demonstrating the potential use of the fibers for sensing and harvesting. I love that. Harvesting human motion. And when deployed in a body of moving water, this is also makes my brain go, wow, okay. When deployed in a body of moving water, they can harvest energy from the movement of waves or currents. Interesting. In another experiment, the carbon nanotube yarns were repeatedly stretched to charge a supercapacitor, which then had enough energy to power 5 small light-emitting diodes, a digital watch, and a digital humidity temperature sensor. Very and no cool. surprise, no surprise at all, the researchers have applied for a patent based on the technology. And again, think about maybe your future jacket or pants or whatever, generating energy to keep your cell phone charged up or whatever, right? I mean, how cool is that? Like trickle energy, really, in this case.
And a little reality check for me is that, something that people don't really know, Ralph, we joke about, the only thing carbon nanotubes and nanofiber can't do is leave the laboratory because, you often hear them in battery technology, cars, all this different science stuff, but you never really see in a practical application. The only concern I have and why I'm sure this is going to be more for different kinds of uses, like they were saying, in the water and stuff like that, is that, fun fact, carbon nanotubes are carcinogenic. They give you the same damage that asbestos does. So, you can imagine that like a carbon nanotube woven, scarf might not be the best idea because then you'd obviously be breathing that stuff out. So you got to be careful with that kind of stuff. But it's
interesting. Well, Yeah, I was going to say, Ben, that begs the question that I would go back to these folks in Texas and say, how do you deal with that? Because you've just raised a really interesting point. I hadn't even been aware of that at all. So that's cool.
Well, yeah. And, they gave a couple of examples where it can, like light emitting diodes. You can imagine that, maybe Ralph, I'm sure that, based on our shared complexion, we go to the beach often. They have that, they have that kind of rope that, kind of sections off a part where the lifeguard is guarding and where there's no lifeguards. And you can have like blinking lights that are powered just by the motion of the waves, by that safety rope being there. Little things like that, I'm sure would be possible. But yeah, I think having it in our clothing, not saying that, asbestos never had a purpose. Like, asbestos was an amazing material. We just found out later that it, kind of did a lot of damage.
Exactly right.
So, I'm sure there are ways to protect ourselves from the carbon nanotubes, but still get the functional properties out of them. You just have to kind of consider that at the same time. But still, very, very cool. And, the idea of just generating electricity from almost nothing, maybe our own mechanical movement, you're right. That's a theme that pops up often. So very cool. And I definitely love the, the little microscopic pictures that they have.
Yeah. Hey, Ben, one thought I just had as we were speaking is with regard to that idea of putting these things into a movement of water or whatever. Wait a minute. What about a flag? A flag made out of this stuff that you could prop up. Maybe you're out camping or you're military or you're on the beach or something, and you put up a little flag where there's a good wind flow, a constant wind flow. This thing could be generating electricity and not, on your body, to your point about the carcinogenic issues and so forth. But there's probably a ton of different possible uses that would be safe for humans, but also beneficial.
Right. And to be clear, when I say carcinogenic, in laboratory tests, when they administered the carbon nanotubes to the airways of mice, they got similar symptoms as asbestos damage and asbestos-related diseases.
Gotcha.
So you're right. Having a flag way up there in the open air probably won't cause much more harm than the sun's own sunshine giving you cancer. But, just something wrapped, we're not going to have face masks that are made out of carbon nanotubes, for instance. So still a lot of applications. It's still a lot of applications, still a lot of use for the research. So I'm sure they have considered that one as well. So there you go. Story number 2, and sorry for being a Debbie Downer, but story number 3.
Oh, I'm glad you did.
Let's go ahead and talk about this one where, this is a new system that can convert waste. And, that's always such a huge deal for, for manufacturing, in turning something that is just thrown away, or worse, you have to pay someone to take away from you. Being able to turn that into a viable product that you can then sell. Hey, it's kind of a win-win. So let's talk about story number 3.
It's a great win-win story. So the headline here is new, all-in-one, and you're going to see the significance of that. Hold on to that. All-in-one system can capture carbon dioxide emissions from industrial plants and convert it into a lucrative product. And again, I want you to keep in mind all-in-one. I found this story on CNBC, and I also went out to the source of the story, to their website. So globally, carbon dioxide emissions from industrial plants are responsible for an estimated 31% of total greenhouse gas emissions. Significant, 31%. So to help combat this, there are 2-step capture and recycling solutions currently being deployed. That's where I want you to remember the all-in-one. Okay, so right now we have 2-step systems. The first step involves equipment to capture CO2 emissions at the plant site. The second step involves transporting the captured CO2 to a processing facility where it can be transformed into useful products, including such things as ingredients for fuel, plastics, and even food, as well as valuable chemicals such as ding, 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 methanol. All right. Now, today's 2-step solutions represent a positive step forward. I think we all agree to that. But here's the deal. What if you could have a single on-site system combining capture and conversion to cut out the time and expense of transporting the captured CO2 off-site? Scientists at the Pacific Northwest National Laboratory in Richland, Washington. And I want to stop for a second. Friends, I'm in the Silicon Forest, okay? I'm in the Portland, Oregon area, and our colleagues in Washington State. This is our MIT. if you don't know about these guys, check out their website. They're doing amazing stuff. And we've talked about them before, Ben, on the show. So scientists at the Pacific Northwest National Laboratory in Richland, Washington, recently achieved this breakthrough by creating an affordable, all-in-one, carbon capture and conversion system. Yes. And here's how it works. The system can take, for example, exhaust flue gas from an industrial plant and strip out CO2 using a patented solvent developed by the lab. The solvent then feeds the CO2 to the system's built-in reactor, where it's converted into methanol, one of the most widely used industrial chemicals on Earth. And this continuous process approach, all-in-one approach, skips multiple expensive steps to release, compress, and purify the CO2. So bottom line, I think this is a real game changer, as this all-in-one solution is the least expensive option today and significantly reduces the cost of making renewable methanol from CO2, which plant operators can sell to help cover the cost of the system and its operations. Wow. What's wrong with this story? Nothing.
Yeah, I really love that it's one step, and I'm hoping, Ralph, that we eventually get to a point where it only makes sense to recapture that exhaust and that waste and sell it as methanol than it is to just let it spew out into the environment. When you're losing money and you're damaging something versus capturing it, making money, and helping the environment, that just seems like such a cool way to go about it. And no one's really worse off for this whole equation. So this one was very cool, and the fact that you can just extract methanol, which very familiar with. It's it's used everywhere, and I'm sure that will have repercussions, not just for the plants using it, Ralph, but of course having more supply of methanol reduces the cost overall of making really almost everything that we touch in our lives. It's very, very cool. So not just the production facilities, but everything gets cheaper because of it. It's a win-win-win, like all across the board.
Yes.
A great job from Pacific Northwest National Laboratory. So with that being said, story number 3, story number 4. We're feeling hopeful about the future. We're feeling happy. Let's talk about story number 4.
Yes, this is really great. And this is in the health category. I always like to try to include a health-related medical technology story. So here we go. New portable electronic biosensor can help detect oral cancer. And I got this story from medgadget.com. That site is fun. Okay, oral cancer detection typically involves a biopsy, which is invasive, expensive, and takes several weeks to obtain results. So that means, they're going to pull a tissue sample out of your mouth. To speed early detection of oral cancer, researchers at the University of Florida have created a small, portable electronic biosensor. You see the board for it in the image there. It's very prototype, that can rapidly detect a known biomarker for oral cancer. So its job is to detect this known biomarker for oral cancer. The device uses test strips, like those used in blood glucose tests, to spot a protein biomarker that can reveal the presence of oral cancer. The device processes a patient's liquid sample that is placed on the end of a test strip, and the test strip then runs into channels within the biosensor device that contain antibody-covered electrodes. And the antibodies are specific for the protein phosphatase. I'm not sure I'm saying this right. Phosphatase 2A. And antibody binding changes the electrical signal the electrodes produce, providing a readout alert if the protein is present. It's a lot of gobbledygook there, but it's basically a detector. And here's why I think this is so important, Ben. The new portable system could be useful in rural and remote regions, not only of our nation, but around the world, where access to expensive conventional lab testing equipment is not available. So again, no biopsy, no sending off tissue samples, waiting for weeks. you've got a portable at patient care site thing. This could be in hospitals and clinics and wherever you can think of, out in the field, in tents, doesn't matter. And this thing could be doing oral cancer testing quickly. So I think this is pretty cool.
And of course, like you said, it's very, kind of at the rudimentary primitive stage, because it just looks like one of those green circuit boards with circuits all over it. I'm curious if they, if they were to produce these things en masse, try to, hit a certain dollar amount and miniaturize it and try to make it a little bit sleeker looking. This would be a great toolkit to have out in the field, like you were saying. What I'm saying is, you could probably make something that's more durable, rugged, and smaller, and have the same results. This is obviously proof of concept, but very, very cool that they're able to do something that's already looks pretty miniature, but could be even smaller and even more life-saving. So very
well, yeah.
very
and
cool.
Ben, you make a really good point. If they get this very cost-effective, which is their goal, and get this deployed. I was just thinking, it just occurred to me this week, I went to the dentist, routine checkup sort of thing. But what if my dentist saw something in my mouth that, maybe there's something going on here? Pulls out this little device, does a little test thing, sticks it in there, and in a few minutes, boom. Oh, you're fine, Ralph. Or, crikey cupcakes, you better go and see, cancer specialist.
Instead of referring you to, your GP or to a cancer specialist, they could just test it right there on the spot. Very, very true. Yeah. Something like that could be in every dentist office across the country. That'd be a great way to do it. So there you go. And as always with cancer, I think we actually have a family friend that just got diagnosed with this as well. Man, Rob, and I know that COVID and, over the past 2 or 3 years, people have been putting off their, their checkups and routine checkups. But I'm sure that, I'm not alone in this. A lot of our family and friends are unfortunately coming down with, little cases of cancer. And although there's no such thing as little cases of cancer, but man, the amount of delaying detecting and delaying your checkups and doing that kind of thing, really, really bad. So early detection is the best thing you can possibly do, and that's why story number 4 is so great. So I like that a lot. And big shout out to University of Florida. That's my brother's alma mater as well. So
there you go.
Yeah,
cool.
Very, very cool.
Hey,
story number
Ben,
4 is.
If we have time, do we have time? I had a little bonus story. Story 5. Do we have time?
Absolutely do. Story number 5. And the nice folks over at MIT have not been sitting around doing nothing.
Yes. I couldn't resist this being an old guy. I couldn't resist this headline. Unique MIT suit helps people better understand the aging experience. And this is from the MIT Newsroom website, which is really great. So we'll hop through this because I know we're running short on time here, but MIT's Age Lab in the Center for Transportation and Logistics, I gotta love these guys, MIT, what can you say, has created an innovative jumpsuit which combines a collection of weights and bungee cords, some unwieldy gloves, and a pair of Crocs, those they're not plastic, but you know what I mean, those shoes, with blocks of foam glued to the bottom of them, as well as red goggles. And what I love about this story, when we talk about MIT, Ben, it's always, extremely advanced and high-tech, blah, blah, blah. This is bungee cords and weights and stuff, but the idea and the intent and the motive, I think, is what's laudable. The bodysuit called Agnes, AGNES, which stands for Age Gain Now Empathy System, is an empathy and research tool designed to simulate for the wearer some of what it might feel like to live in one's early 80s with a few chronic health conditions. The weights approximate muscle loss, the bungees, the reduction of range of motion and flexibility that can affect the joints with age. The foam platform Crocs simulate the erosion of balance, and the heavy, awkward gloves evoke the loss of tactile sensation. Finally, the red goggles simulate a range of impairments to vision, from impaired acuity to diabetic retinopathy. This is very depressing in some respects. But they're trying to help us, old people. The goal is to help designers, engineers, executives, and helping professionals understand a little better the physical and social world of people in their 80s and beyond, so that they can design better products and services for older users. That's the upswing part of the story. Agnes has been used globally to inform the design of public transportation systems, interesting, retail environments, medical devices, and product packaging. So at first year seems kind of depressing to think about all the problems old people have, but it's an upswing when you think about what MIT is trying to do and the fact that this jumpsuit of theirs has been used globally to help in so many ways. I love the part about transportation systems particularly.
Yeah, and I never really considered that. Like I thought when they needed to test a system to see if someone who's 80 plus could use it, I thought they just went out and found an 80-year-old and it's like, hey, you want to help us study some stuff? And they're like, yeah, sure. And then you kind of go about that, but. To have this suit, and I definitely like the appeal of it, Ralph, because like it's not just an 80-year-old, it's you. Like if you're the one in the suit, it's you at 80. It's with your range of motion, your body that you currently have, plus an extra couple of decades. Very, very cool. And by the way, fun little fact, you included the picture in the show notes and of course on the website right here. Do you recognize that gentleman getting strapped up?
No, not offhand. I didn't catch on to that.
That is Mr. Chris Hemsworth. Yeah, there you go. So Thor from Guardians, or not Guardians of the Galaxy. Wow, from the Avengers, Thor and
no kidding. Oh my gosh, I totally didn't get that.
Yeah, so in the caption for the picture there is Chris Hemsworth is outfitted at the MIT lab, Age Lab's Agnes suit in a recent episode of Limitless with Chris Hemsworth. So
cool.
Yeah, so just a little bit, and of course, if you poke through the slideshow, you can see Chris Hemsworth on like a mobility scooter, for instance. So seeing how helpful that is for someone to have that in their life.
Sure.
So, yeah.
And Ben, cool. you raise a good point. One final thought I have here on this is the idea that you're a designer, and the designer of technology today is probably someone who's not retired and in their 80s or 90s, right? They're going to be people maybe in their late 20s, 30s, 40s, that sort of thing. And the idea as a designer to personally and physically experience what your target audience is going through every single day is dynamically different than just saying, let's get an 80-year-old down to the train station and see how they, hobble onto the train or try to find their seat. You personally experience it. That's, as a designer, would be so much more insightful than observing. Not to put down your idea of the observation. That's great. But really to personally experience, your brain would go, oh, I get it. I need something to help me do this movement, or I need something to. So that's what I love about this story.
No, it's really putting yourself in someone else's shoes and, really
yes, literally.
Yeah, literally. And I will say that, there's one little twist where, of course, for a researcher to put this on, they're dealing with it for an hour, 2, 3, 4 hours. For a person living like that it's every day, every hour. So a little bit different mental, but at the same time, it's to make everyone's lives easier. So big shout out to MIT and the Age Lab, something I didn't even know exists until just now. So good job, Ralph. Good job, everyone out there, for listening. And ladies and gentlemen, we'll be back next week with even more stories. Thank you again. Catch Ralph here, of course, every Friday, and catch him over at WKEX Portland, Oregon at the Mark Mesa Show. Have a good one. Bye-bye.